Hello everyone, my name is Randall and today we'll be looking at machine learning. Hopefully, by the end of this video, you will understand what machine learning is and how machine learning is used in today's society. So first of all, what is machine learning? Well, machine learning is a system with the ability to automatically learn and improve from experience without being explicitly programmed. Machine learning focuses on the development of computer programs that, when given data, they are able to use that data to learn by themselves. Now, you may not have noticed, but you probably have come across machine learning systems or used them before. An example of a machine learning system that you might have heard of is Siri. Now, Siri is a voice-activated assistant similar to Alexa, Cortana, Hey Google, and Amazon Echo. Now, these voice-activated assistant listens to your instructions and when possible carries them out. They can do a lot of different things such as open apps, play your favorite music, and they can even tell you a joke. Now, do all human beings sound exactly the same? The answer is no, we all have different tone of voice. We all speak at different pace, some fast, some slow, and we all pronounce words differently. Some would say tomato, and some would say tomato. Some would say scones, some would say scones or scones. Now we all have different voices. Some are very similar, but most of the time it is often the case that we all sound different from one another. Now, did the developers of these voice-activated assistants went round the earth recording everyone's voices so that their systems will work whenever anyone uses them? The answer to that is no. But what they did do is they recorded maybe a few hundred people's voices, or maybe even thousands, or thousands of thousands, and afterwards they used those recordings to teach a computer or a system to recognize a person's voice and activate only when they say things such as "Hey Siri" or "Hey Alexa" or "Hey Google." Oh, sorry, I mean Alexa. Now, this is why anyone can use them, even animals such as parrots. If you had a parrot that said Alexa to the device, it would activate. Another example of a machine learning system you might have heard of, but didn't know it was a machine learning system, are security cameras. Before, security cameras were just normal security cameras. They normally would link to monitors where a human being watches them. This human being would often be staring at multiple screens, let's say 10 at once, okay, trying to monitor what is happening. Now, let's say we needed to find someone important. This person would have to stare at these monitors all at once without having any breaks of food or drinks. Whereas a computer can monitor hundreds or even thousands of monitors at once without needing food or sleep. This makes it so finding someone important more efficient and spending less money and time on hiring people to do the same thing but in a slower fashion. Now, these security cameras are able to recognize a person using something called facial recognition. They can even recognize objects. So nowadays you have security cameras that recognize someone's um, license plate in a car, so that if someone was to break the law, they would be able to recognize the numbers and the letters in a license plate and be able to notify the police of who have broken the law. The same thing with facial recognition. If a computer was showed or shown an image of a person's face um, that we're trying to find, then the computer can scan all of its monitors looking for that person's face until a match has been found, and then they can notify whoever is needed to be notified. Another example of machine learnings um, are games and apps. Um, there is an app called Draw It where um, where you have four human players competing with each other. They choose one out of the two categories that are displayed and they try their best to draw them. If they draw those categories well, the computer will make a guess, and if the computer guesses correctly, the person gets a point and moves on to the next set of categories. The person with the most points at the end wins. Now I've got a video here that I will play of us playing this game. So as you can see at the very top, we've got four people playing. At first, I tried to draw a star, and I was able to draw it correctly. Next, I had to choose between moon or castle. I went for moon, and the computer guessed correctly. I did the same thing with squiggle, and this time I went for butterfly. But notice here, even before I finished drawing the butterfly, the computer was able to guess it correctly. In this instance, I tried to draw a school bus, but the computer kept guessing car. So I thought maybe I'll draw a carrot. It seems easier to draw. But as you can see here, I was trying to draw a carrot, but the computer kept guessing that I was drawing an arm. I kept trying, but in the end, someone else beat me to it, and they had more points than I had, so they won. Now, the reason for the computer guessing that I was drawing an arm when I tried to draw a card was probably because whoever developed this game or made this game gave the computer images of different drawings of an arm. And it happened to be the case that when I was drawing an arm, it looked more like the arm that they've drawn. Therefore, the computer was guessing that it was an arm because it looked more like an arm in its database. There are even machine learning computers that can play chess. Um, these machine learning computers that are able to play chess have challenged world champions in chess and won. Computers can think faster than humans, so that when a person makes a move, or when the champion made a move, the computer already planned various different scenarios or situations where they will be in a winning position. So no matter what the human being did, the computer already knew what to do next so that they were going to win. Now, machine learning is also used in robotics. This robotic arm, as you can see on the screen, is a table tennis bot. Now, this company called KUKA, if I pronounce that correct, built this robot and then challenged a champion in table tennis. Now, I won't play the video, but I recommend sitting down with your parents and going on YouTube, searching for KUKA table tennis bot. Watch the video and see who wins. It's a very exciting match, good to watch, and it's actually quite interesting regarding who won at the end. Now, how does machine learning work? Well, machine learning works by using something called pattern recognition. Pattern recognition is the ability to recognize patterns in datasets. Computers can learn from patterns. For example, a computer can learn the difference between photos, such as the shapes and the color used. Now, at this point, I would like you to pause the video and go on the quiz. And the link for the quiz is on the same page as this video. Go on the quiz and complete the first section of the quiz called pattern recognition. Then replay this video. Now, hopefully you have gone through the pattern recognition quiz. What I will do is I will go through two of the patterns shown in that quiz. This is the first pattern shown. Now, the way we as human beings would tackle this problem is by first looking at the pattern in the sequence given. Now, I can see two different patterns in this example. One pattern is that each color goes down each time. So as you can see, the blue is at the top, then it goes down by one, and it becomes here, and it goes down by one, and it gets to this position. And so does the green. As the blue goes down, the green goes down with it. The same with the yellow. But then the second pattern that I can see is when a color is at the bottom, it becomes the top color on the next sequence. The same thing happened here. The red is at the bottom at this sequence. At the start of the next sequence, it becomes at the top. Now, computers learn the same way by eliminating incorrect answers. For example, we know that at the bottom of this sequence is green. Following those two rules that we've learned, if green was to go down one, and because it's at the bottom, it must be at the top of the next one. Now, out of these four choices, A, B, C, or D, there are only two with green at the top. So we eliminate C and D because we know that they're not the right answers. But now, how do we figure out which out of A and B is correct? Now we look at the first rule. If colors goes down one step each time, then green must be the top. Ticked, we've done that. The second rule is if the color is at the top, then the next color at the bottom will be the one above it. So as you can see in this sequence, if green goes at the top, then blue must be the color at the bottom. Now comparing A and B, the only one with blue at the bottom is B, thus eliminating A and giving us the correct answer B. So the computer works the same way as we've done there. We look at the pattern in the sequence given. So imagine this as the data given to a computer to learn what the pattern is. The computer, if given good examples of data, can then learn the pattern that's happening. And from that, it uses elimination, as we did step by step, to figure out what the right answer will be. Okay, so if I move on to this one, okay, what comes next? Two patterns that I can see is that at each time, the number of sides or corners of each shape increases. So a triangle has 3 corners or 3 sides, then a square has 4, then a pentagon has 5. Following this rule, we can say the next shape in this sequence should be a shape with 6 corners. Now looking at our options, we can see that we already eliminate B, C, and D because none of these have six corners or sides. That gives us the options of A or E. Now the second pattern that we can see is the colors themselves. The colors go from red, orange, then yellow. Out of A and E, if we were to put E next to it, it wouldn't be following that color pattern. Therefore, we have eliminated all of the rest and found that A was the answer. Because A has six sides, it's a hexagon, and A also follows the color pattern, which is red, orange, yellow, green, which follows the pattern of a rainbow. Now, how can we model machine learning in something more fun or something more visual so that we can see what exactly is happening? Machine learning can be used in Scratch, and hopefully after this tutorial you'll be able to see the worksheets provided in the same page and also video tutorials going through those worksheets for you to do along with me. Now let's say we want to be able to train a computer to sort a set of photos in two piles. One pile of photos of butterflies and the other pile photos of dragonflies. How do we start this process? What do we need? Now with machine learning, the first thing you want to do is create data sets. So in this scenario, we want to teach the computer the difference between butterflies and dragonflies. So what we do is we create separate containers for each one. One bucket or container filled with images of butterflies and only butterflies. What you want also are different images of butterflies at different locations, not one type of butterfly all in the same location, as you can see here. Another thing to do also is you want the same number of images of butterflies and the same number of images of dragonflies. So in this example, I've got 10 of each. Okay. So now that we have those two containers, one just filled with different types of butterflies at different locations, the other filled with different types of dragonflies. As you can see, they've got different colors and at different locations. We now give it to the computer to train. We train the computer using these images so that they can see the differences between them. Now, the computer, hopefully, once given these two containers, will see that butterflies have sort of wider wings. Okay, and then you've got dragonflies, which often have clear or transparent wings and longer body. And as you can see, the body of the butterfly, some of them can be quite long and thin, but most of them are quite small and wide. But dragonflies are often quite long and thin. Okay, so hopefully using these data sets, the computer will able to pick up those patterns, the pattern of the butterfly, the pattern of dragonflies, and what they look like. Once we've given our computer these two different data sets, and we train the computer using those informations, we essentially tell the computer this is an example of a butterfly, here's another example of a butterfly, and we do that 10 times. Then we do the same with dragonflies. We say this is an image of a dragonfly, here's a different image of a dragonfly in a different location, and we do that 10 times. Once we've done that, we write code so that if the image that we're showing the computer has similar patterns or features as a butterfly, then we want to place it on the left hand side or a left pile. Remember, our aim is to give the computer or the system, let's say 20 images of mixed images of butterflies and dragonflies, and they are to sort it. The computer is to sort all the butterflies on the left and all the dragonflies on the right. So here, that's exactly what we're coding or programming the computer to do. If it recognizes that the image that is being shown has similar features to a butterfly, then we place that image to the left. Else, if not, then we're going to say it's a dragonfly and we place it to the right. Now let's have a look at this video example. I've made a Scratch program where hopefully it will separate images of dragonfly to the left and images of dragonflies to the right. But in this example, it's without machine learning. It's without a computer that has been trained to see and differentiate between dragonflies and butterflies. Let's have a look at what happens when we show it images. So first image is dragonfly, and it places it correctly in the dragonfly pile. But then the next image or images are random images of butterflies and dragonflies. But as you can see here, no matter what image comes up, whether it's a butterfly or a dragonfly, it is sent to the right, saying that a computer has guessed and thought that it's a dragonfly. As we can see, various images here, and here, these are all butterflies, but the computer has placed them in the dragonfly pile. Now the reason for this is without machine learning, the computer doesn't know the difference between the two. And all it's done is said, okay, I don't really know what this image is. I'm just going to pick one or the other. I'm going to say that it's a dragonfly. And it does that over and over again. It keeps saying, I don't know what it is. My default guess is dragonfly. So I'm going to put it in a dragonfly. And that's why it's not separated them into butterflies or dragonflies. But now let's look at a video with machine learning. This is a Scratch game where the computer has been trained to recognize the difference between a butterfly and a dragonfly. And then when we give it random images, it should be able to tell the difference between the two and separate them correctly. Okay. Now, as we can see, I believe the computer has done well. I believe that all images of butterflies have been placed to the left and all images of dragonflies have been placed to the right. Now, has the computer made even one mistake? The answer in this case is no. The reason for that is we've given it enough data so that it's able to understand the difference between the two. But sometimes the computer can get it wrong, even with given can get it wrong. The reason for that is maybe the data that we've given is not enough. So we need to give it more examples of different butterflies at different locations. Now I want to point out here that these images that I've shown the computer in the Scratch games, some of them are already images in the containers or the buckets from before, but some of them are completely different images that have not been in the containers. So if I scroll up and show you, okay, so if we look at the butterfly section for now, okay, really quickly, and then if I go back down, as you can see, oh, sorry, if I just skip this video to there, as you can see, this image of this butterfly was not in that container. The machine learning system has learned that butterfly images with the same features as a butterfly Doesn't matter if it's not in the container, is a butterfly. Okay, and it's the same with dragonflies. And that's how a machine can learn. What we can do is we can add more images to the bucket. So let's say we take this image, we place it into the butterfly container, and we do the same with dragonflies. It's good to have equal amounts of examples for each container. So the one I've shown you, there's 10 butterflies, 10 dragonflies. Let's say we gave it 100 butterflies, 100 dragonflies, then our machine learning system will be more accurate. Okay. Just bear that in mind. It actually has learned, even if it's not been given that particular image of a butterfly, that it's a butterfly. Now, what I would like you to do is I want you to go back to your quiz and complete the second section of the quiz. This section of the quiz is all about machine learning.